Hi everyone and welcome to Scratch Animation 3. Here's your starter for today. I want you to have a look at both sequence A and sequence B based on last week's coding and see which one you think is incorrect. Write down in your jotter or on your worksheet which one you think is wrong and why. Okay, let's move on with today's lesson. Today what we're going to be looking at is focusing on movements and in particular coordinates, okay? You'll be successful in your learning if you can understand the importance and the use of coordinates in Scratch, if you can move sprites easily around the screen, and understand the use of loops to make your coding efficient. And we're going to talk about coding efficiency a little bit later on. Firstly, what I want to start off talking about is coordinates. Okay, now coordinates are very important in Scratch because quite often we have to tell a character or a sprite where to appear on the screen or where we want it to move to, and in order to do that we need to understand what the coordinates are. Okay, first of all I want you to imagine that this rectangle signifies the stage that your sprite animation or program is created on. Okay, now on that stage, what you don't see, sorry, is that it's actually got two axes. Across the middle, it's got the x-axis, and up and down the middle, it's got the y-axis. Okay, and both of these points meet in the middle of the stage at the coordinate x0, y0. Now, the x-axis is actually slightly wider than the y-axis is tall, and this is mostly due to the fact that if you have a look at your actual laptop or desktop screen that you're looking at, many of those will not actually be a perfect square. A lot of them will be a rectangle where you've probably got a little bit of widescreen going on there, and the Scratch environment has been created to kind of mimic this a little bit. Okay, so the x-axis is actually wider than the y-axis. Today we're not going to focus on the actual coordinates themselves, but what we are going to focus on is the sign of the coordinates. So whether the coordinates in different areas of the background are positive or whether they're negative. So first of all, what I want to do is have a little look over at the top right hand side here. Okay, this area, all of the coordinates are positive x and positive y. That's because we're on the positive side of the x-axis and the positive side of the y-axis. Now you may have done coordinates at primary school, you may have done them in maths already, but usually sometimes when you see a y and an x-axis you actually only get this part of the graph and you don't do negative numbers. So if you haven't done them before, don't worry, we'll go over what they mean. But anything in this area has a positive x coordinate and a positive y coordinate. Okay, let's flip over and look at the opposite side. Okay, this part of the x-axis is the negative part of the x-axis, and down here is the negative part of the y-axis. So that means that across here, all of this section, the x-axis is negative and the y-axis is negative. Okay, so any coordinates in here are negative, and I'll show you some examples to help consolidate this. Down here, the x-axis that we see is positive and the y-axis that we see is negative. So all the coordinates in this area have a positive x coordinate and a negative y coordinate, and up here is the opposite way around. We've got the negative x-axis, positive y-axis, so all the coordinates of x are minus something and all the coordinates of y are positive something. Okay, so just to recap, this area, positive x coordinates and positive y coordinates. This area, negative x coordinates and negative y coordinates. Down here, we've got positive x coordinates but negative y coordinates, and up here we've got negative x coordinates and positive y coordinates. Now, if that wasn't complicated enough, what we also have is the issue of these axes themselves. Okay, if we have a sprite that happens to be positioned right along this x-axis, what that actually means is its y coordinate is equal to 0. Okay, so it's got a 0 y coordinate. If we measure it against this scale, this is the point 0 in the middle. Okay, so it's got a 0 y coordinate. In turn, if we have any sprite that appears somewhere up the middle of this y-axis somewhere, it doesn't matter how tall or how short it is or where it is on that line, it'll have a negative 0 coordinate. Okay, and that can have an impact too on the coordinates. It doesn't have a sign, it's just a 0. So let's look at some examples. Okay. Before we do, let's have a look at the shapes of sprites, because it's very important to consider when we look at even just the scratch cat, they are not solid shapes. So if we have a look at it here without the square around it, they're very strange, weirdly shaped objects a lot of the time, and some of them are really, really wide, some of them are very tall, some of them are very odd shapes indeed. So what we have to imagine is a rectangle around the outside of our sprites. And if we were to draw a line from here to here, and a line from here to here, and plot the middle of this sprite, it would be somewhere down here at the bottom of this cat's chin. Okay, and what we have to do is when we're thinking about what the coordinate for our sprite is, we need to imagine it's right in the middle of that cat. And the reason it's in the bottom of this guy's chin and not maybe in his nose or something is because the size of the cat's head compared to the size of the body. So imagine drawing a rectangle around the outside and a big cross through the middle, and the middle point is the easiest way to do it. Okay, so what I've done is for all the objects, the ones on your worksheet and the ones on the next slide, they've all got a purple circle in the middle to help you determine where the middle of the objects are. Okay, so we've got 3 cats here. Orange cat, blue cat and a green cat. They've each got their own little purple dot to help you think where the middle is, and we're going to have a look at their coordinates and try and decide not what the numbers are, but whether the coordinates would be positive, negative, or whether they would be 0 and have no sign. Okay, so let's start off with this orange cat. He is in the positive side of the x-axis, which means his x-coordinate is going to be positive, and he's in the positive side of the y-axis, which means his y-coordinate is going to be positive. Okay, have a think yourself for a wee second about the blue cat and decide whether or not you think his x-coordinate or his y-coordinate would be positive or negative. Okay, the answer is this is the positive side of the x-axis, so his x-coordinate is going to be positive, but this is the negative side, the bottom side, of the y-axis, so his y-coordinate is negative. Okay, let's have a look at the green cat, see if you can work out for yourself, and I'll go over in just a second. Okay, the green cat is a little bit more complicated, okay, because you'll see that that purple dot is right on that blue line. Okay, however, if we look at where he is on the x-axis, he's not on the positive side, he's on the negative side, so he still has a negative x-coordinate. But where he doesn't have a coordinate, because he's not on the positive side, and he's not on the negative side, is the y-axis. He's actually smack bam in the middle. So for this one, his y-coordinate is just the number 0. Okay, so that's the type of thing I want you to do. Use that for your worksheet. If you're not sure, take a guess. You've got a 33.333% of being right, because you can only guess plus, minus, or 0, and give it your best shot in the worksheet. Now, before you go across to creating your program in Scratch and finishing off your questions, I wanted to look a little bit at code efficiency, and in particular, the use of repetition within Scratch. Okay, there are 3 different types of loops in Scratch that we can make use of. The first one is the forever loop. Now, basically, the forever loop will just repeat whatever instructions or code you put inside it until it will keep repeating it until the program stops running. Okay, so it's not a set number of times, just does it as many times as you like. Okay, you also get a repeat loop where you can pick how many times it wants to loop round. Okay, and this one in particular, it's just 10 times as default, but you can change the number in here to be 5 times, 50 times, 1,000 times. You can decide. Okay, the last one, which we might use a little bit later in the course, is called the repeat until loop. So it's repeating until, and then this special hexagon leaves space for a blue sensing block or something to go in there, so it can repeat until a specific condition is met. So it might be, if it was a game, repeat until the score is equal to 10, or repeat until the level is 2, or repeat until the lives equals 0, or something along those lines. Okay, so let's have a quick look at some examples of code and see how we can make them more efficient. So here's a first one, right? We've got, when a cat is clicked, it turns 36 degrees, waits 0.01 seconds, which is a very short period of time, turns 36, repeats, turns 36, repeats, turns 36, repeats, so on and so forth, and keeps going down until the very end. Okay, now it doesn't take a genius to work out that this is the same 2 instructions repeated once, twice, 3 times, 4 times, all the way down to the 10th time, which basically means the cat starts facing one way up and will repeat a complete spin until it's facing the same way again. Okay, now we can duplicate that code without having to have it written so many times by putting it inside a repeat 10 loop. Okay, so we repeat 10 times, turning 36 degrees, waiting 0.1 seconds. This small piece of code will do the exact same as this large piece of code. Okay, it's the exact same coding, just repeats 10 times. You can easily spot a loop in Scratch because it has this kind of C shape and has space for the code to go inside it. So you can see where it stops and you can see where it starts and you can see where it stops. Let's have a look at another example. Now for this one here, you notice we've got a collection of the same instructions and also the same instructions down here, but we've got them split up by these two different instructions. So we're not going to be able to put this whole thing into one loop because we need these two extra separate turning instructions to be separated out. Okay, so that code would be changed to look like this. Repeat the first two instructions 5 times if you count it. 1, 2, 3, 4, 5. So this is replaced by this. We still have to turn 180 degrees, and then this whole section is replaced by this. And then we turn 180 degrees. And this whole code for the bat is the exact same one as this one, apart from for some reason this is bat 1 and bat 2. Don't know why that is, but basically the rest of the code is the same. Okay, the last one we've got when the dino is clicked, change Y by 20, weight, change, but you'll notice when it gets to here, it changes by -20. So these 4 sets of instructions are different to the first 4. So again, we can't put them all in the same loop, okay? So that one changes to repeat 4 times and repeat 4 times. So it goes up 4 times on the y-axis, then down 4 times on the y-axis, okay? So before we go to the plenary, let's have a little look at what you are doing today. Today, what you're going to do is you're going to make a fish tank, all right? So I want you to import the underwater background and these 3 sprites, the starfish, the octopus, and the shark. Now, over the page, it gives you the base code for each of those, okay? So it gives you the code for the octopus, the code for the starfish, and the code for the shark, noticing that the shark uses 2 of its costumes. You'll need to make sure that they have been imported when you import the shark Sprite from the Sprite library. Now, it shouldn't take you too long to put those bits of code together. You're practicing your use of loops, so notice how in the octopus here the forever loop goes all the way around, and then we've got 2 repeat loops inside this. So he goes up, and then he comes down, and then that whole thing is repeated. So we've got lots of loops inside loops here. Again, the starfish has got that as well, loops inside loops. So a little bit of messing about with your code here to try and get that working just right, okay? Once you manage to get those 3 working correctly, your ninja task, however, is to try and fill your fish tank with as many underwater animals or vehicles or people as possible. So if you want to have divers coming in, if you want to have seaweed swaying at the bottom, if you want to see the bottom of a boat perhaps move across the top of the screen, I want you to use as much code as you can, play about with it, and I want to see really cool virtual fish tanks or aquariums. And again, if you want to tag me on Twitter to show me what you've created, that would be brilliant to give us an idea of where your programming skills are at so far. Okay, back across for our plenary to finish us off. So the last thing I want you to write down after you've done your worksheet questions today is, what do you think these 4 scripts do? So the first one is change x by 10. What do you think that does? The second one, what does repeat 10 do? What type of block is it? Number 3, what does next costume do? And number 4, what does when green flag clicked do? Okay, so just a short description on your worksheet of what these 4 blocks do. And then before you finish up, the last thing you need to do is to reflect on how successful you think you've been today. Okay, so do you understand the importance of coordinates in Scratch and how they help us to move sprites about the screen? Can you implement and move your sprites across the screen using different types of code? And do you understand the use of loops to make your code more efficient? Next to each of these things, pick whether you feel you're 5 stars, 4 stars, 3 stars, 2, or 1, and use that to help you move your revision and stuff forward when you want to try things again next week. Okay, any questions, just let me know. And remember, the answers to last week's worksheet will be included with your Show My Homework upload. Okay, speak to you later, guys. Have a nice week. Bye.